we'll keep pushing forward. We're going to hear from Sean Audain, who is the City Innovation Lead with Wellington City Council, and he'll be presenting on digital twins and resilience building, how some of the social agency twin components helped the Wellington City Council respond to COVID and where that momentum is taking us. So that's very, very interesting and timely, because I guess it's fertile ground right now for New Zealand to be thinking about what's next for us. So Sean, if you are still with us, share your screen. Yep, perfect.
Yep, now let's see, how do I share screen?
There should be a green button at the center, I think.
Yes,
yeah.
Yes, sorry, it's very obvious once you pointed out. Very good. Excellent. So, yes.
We're not yet seeing it, Sean. If you can click on the,
oh yeah, there you go.
There you go.
Yeah. Oh, I like that backdrop. Very nice.
Thank you. I like lighthouses. They do a useful job. So my name's Sean. I work for the Wellington City Council. I look after the smart city and digital strategy stuff, but also I am the intelligence planning and foresight manager during a civil defence emergency. So because Grace talked to you so well about earthquakes, I thought I'd talk to you about pandemics, because it's quite fashionable at the moment. So when we're talking about a digital twin, we're talking about something that looks a bit like this. So this is the current computer model we're using of Wellington. What you see is what happens when you start combining asset data with LiDAR and sensor data with parametric, so model-based data. There's BIM, there's all sorts of things mushed together to start giving us that copy of the city. That copy of the city can then have things infused into it. So I thought we'd show you a bit of what behind the scenes look like with COVID. So into those models, you had statistics like these being pushed. So this is what was coming from the Ministry of Health, from Regional Public Health, from the Regional Civil Defence Headquarters. Basically everything we needed to understand where are the cases, what is the impact of those cases, and where are the vulnerable populations. And so by putting all this together, we started to generate that situational awareness, and we could then start to respond. So what that started to look like was things like this, where you've got, say, the food response. So one of the things we realized very early on was that the lockdown provided us with a once-in-a-lifetime opportunity to invest in the city's social services. And we took a bit of a different tactic to many cities, in that we identified which partners whose job it was to do this, who had the pre-existing relationships with people, and we used our powers as a city to help them. So we gave them access to our stocks of PPE, we gave them monetary guarantees to make sure that they had the fiscal confidence to do things. It was around using those local connections to help the central government do its job. So one of the things we did was we used our knowledge of restaurants through our public health regulation to direct the buying agents from social development to those restaurant consortiums, so we could buy the food that was left in the restaurants when we shifted levels. We could then take that food to the apartment building we'd taken and given people who were homeless or without bubbles a place to have a bubble, and then use that food to feed them, to support them, bring in the addiction support from the district health board. And key to making this happen was the ability to see what was happening. So we were helping these organizations report to us, give us the data we needed at a level that could make the fiscal system work. So we could grant money proactively to them. We could see how that money was being spent. And so that the effort went to the front line rather than to the accountants at the back. We also, behind all of this stood basically an infrastructure of trust. So one of the things we realized very early on was, because we're dealing with a pandemic, it's a medical emergency, you need to know a lot about people, and that creates privacy problems. So we created an operating system for privacy, essentially, of how we assessed it, how we looked after the impacts. That resulted in things like the contact tracing system that was implemented through the city. So we were left with, like the rest of New Zealand, at the transition down levels to level 2, without a contact tracing system, a digital contact tracing system. So what we did is we worked with regional public health, the people we'd been working with through the whole thing, and basically with them worked out how we would assess a privacy system that kept the data with the users, obeyed Māori and Indigenous data sovereignty principles, and also meant that the people who needed to be contacted by regional public health could be. And so we ended up picking Ripple. We rolled it out to 800 businesses through the city, all of council sites. And we got to about a 20% uptake, which was pretty good actually for a digital app. But it also provisions systems like this for making decisions. So that model is interactive. I won't move it because it uses a lot of data, but each one of those spheres contains all the details about hotel rooms, what type of suite they are, how they're connected, what sort of facilities are there. This is how we started to work through the quarantine and how we would quarantine particularly the film crews coming into Wellington and make sure that they could be kept segregated and safe from our citizens. We also started doing experimentation with mobile-based data to see that the lockdown was working and to understand the mobility of different social sections of our society. So one of the things we discovered was that those in the three poorest deciles of the city, their movement was 4 times greater than those in the wealthiest deciles. We also could work out which communities were joined to which. So at a community scale, what did bubbles look like? So for example, Karori in the west was joined to Thorndon and to Newtown, largely through the essential workers, people who worked at the hospital in Newtown and people who worked at the emergency response or wanted to go to the bigger supermarket in Thorndon. And then you've got the more realistic twins that were worked on. So whilst this was all going on, we needed something to distract ourselves, so we worked on making this, which is a new generation of technology sitting on top of that stack, because you can have all the data in the world, but if you can't turn it into information and you can't make a decision with it, it's largely decorative. And so this is where we're heading now, with pulling all of these different systems together to effectively dissolve the jurisdictions that help stop the jurisdictions which sometimes get in the way of making decisions. If you think about it, we solved homelessness in 2 days. There's no reason why we can't solve it permanently if we can capture that same kind of energy. And so this is what we learned. The key one, I think, was about that infrastructure of trust and being conscious of how we support it and how we use it. The other one was around the test of, it's all very well to come together, and that's great, but how we fracture apart again is just as important, and how you transition out of consensus in a way that sets you up to come together again. I think that's my time, so thank you.
Yeah, wow, fantastic. That was really interesting. Thank you so much, Sean. I was jotting down quite a few questions in that presentation, but we have our final speaker, so thank you everyone for bearing with us. We're going to hear from Nishantha around how big data analytics can be used in networking cities with data privacy issues. So,
yeah.
Okay,
good
great.
Morning all to, yeah, good morning all. Right, nice presentations. New area for me, so I'm from the different background. Let me share my screen first. Yeah. Can you see my screen?
Yeah. You're still on the last slide.
Sure. Okay. How about now?
Yeah,
Perfect.
that's good.
Great.
Yeah. Yeah. Okay. Yeah. My name is Nishantha from Auckland. I'm working in industry, but my field is different than this is what we are talking about, the smart cities and resilience. But my expertise in AI and machine learning. So I heard a lot of concern about the data privacy and this right to use the data and data democracy. So in this presentation, what I'm going to reveal you the how do you solve this problem, especially in the big data area. So we are handling not the megabytes now. We are handling the terabytes data to build your own machine learning models. The problem is the data is not yours data. It's maybe several institutional data. So how do you build the model, keeping this data privacy, and apply your models? So now the problem is the traditional machine learning is, you know, that it is all the centralized machine learning models. What it means centralized is that you take your data into central position and you do whatever you want to do and you build the models, right? This is the main drawback of current models, because data privacy is the highly concerned in this. So then what we have to do, right? What we have to do is we need to decentralize. So we are not taking all the data into one location. We keep the data as it is. Then we are trying to build our models using the data, keep their rights, keep their privacy as it is. So the solution, now the emerging technology is coming on, but this is still in experimental level, but people are trying to use this one, which is known as federated AI. You may heard about this, the federated AI. So how do you keep this data decentralization and build your model? Let's talk about this. What's the problem in this centralized machine learning models, right? So whatever situation now, what we try to do so far, we bring all the institutional data into one place and then build a model. So this is the issue that as you said in your several speakers, the trust of the data, whether you are going to trust the data. Thinking that, so you can build your proof of concept using samples data, or you can anonymize this data, but it is not the big data era, because now we are using the deep learning era. So we need to use the billions of data to be used. So the data privacy now, you know, so people are putting this lot of regulations and restrictions of using the data. Several cases is happening in recently, right? And then they put as much as the regulation to control the data privacy. So GDPR in this general protection of the data, or you can have especially for the medical data, which is highly privacy data. So they have put in several acts on to control this data privacy or data which is misleading by the other people. So that is the drawback of this centralized machine learning models. So is there any alternative on this one, right? So how do you keep the privacy or the right to use the data and build our model, especially in your case, right? So we know that you are sharing the data with the council, you are sharing with the data with the transport board, or you can share with the data with the hospital, the medical council, DHVs. We need to get this all data into one to build the model that we are going to have a smart cities in everywhere. Not only that, so we have several cities need to be connected. So the cities belong to the several councils. They are not sharing the same data with the central location. So now then the solutions comes in, which is known as federated AI. So the institution is keeping as it is, but you are taking the data. The advantage is that, so you are not taking any data into your location. So what you do is you just try to encrypt data somehow or other and build your own model. In several approaches they do now. Currently what they do is they will make the training of the data in the separate location, and take out all the parameters that has to be aggregated into the federated server or in the central server, which is not keeping any data. What you are keeping on the parameters that you have been trained in each of the location and bring into one. So then what you do is so this architecture is same as this. What you are doing is the API, the client server architecture, but here what we are serving is we are taking is the encrypted the information, which is basically is the parameters that we need to optimize the model in the central location. Still, there are several architectures they're talking about this one. Either you can do with this, not the raw data. You can have some aggregated data into taking the model. Even that has some information that can be collected or that can be violated for the privacy. Therefore, most of the approaches, what they do is they will train the model in a location that the data we are sit on and take the parameters out on that one. So from these, then we can have the central model working on a central server, which is known as the federated server, that will keep all the aggregated parameters and in the final models. Once you build the model, this one, then you can then go back to the location that your data coming from for the various. You can serve the model for that central location, the particular location for the particular purpose, or you can take this all and we have a generic model which is run on a federated. So this way, now the people are trying to overcome this data privacy, as well as all the issues comes with the using the others' data or in the institution data to train your model. So this approach is now people are trying to talking, or the scientists are researching a lot on this one. But this is not that much as easy as that we are doing in central location and train the model and serve the model. But however, this is the emerging technology comes in to solve these, all the data practices or data governance that we are the bottlenecks that we have facing in the current situation. So in this presentation, what I try to introduce, so there is an approach to solve this data problem of data privacy issues and this the restrictions of the data we are getting from the other institutions, other organizations, and the technology is popping up. So my wish is, so we need to think about in this way to get the good smart cities, as you said, like for better world with the better AI, which is not harmful for whatever the humans or anybody. So this is my presentation. Thank you very much for giving this opportunity. Right. So that's what. Thank you very much.
Cool.
Yes.
Thank you. Thank you for your presentation.
Yeah.
Right. So
Yes.
So if you could stop share.
Yeah, sure. I'm sure.
See each other.
Yeah.
Thank you so much.
Yes.
Yeah. So I guess we're on our last
The last stretch, everyone.
Thank you for the interesting presentations and the questions that you have raised so far. So we open the floor for people to ask questions to Sean, to Nishantha, or to anyone else in this room.
Well, I have a question to Nishant.
Yeah.
Actually, as you told me, as you just informed that instead of taking the raw data, it would be good to consider the aggregated data. So while doing the pre-processing stage, the quality of data will get degraded, right? So how to handle that kind of situation?
Yeah, of course. So it's a good question. So as I said, there are two approaches. One thing is that we don't want to, even though we are taking this aggregated data, there are some information inside that one, and that will violate the data privacy. So the alternative for this one, that you train your model right inside the particular location that the data sits on, and take the parameters of it, or which is a model specific parameters. That is, there is no particular information that one. So that, as we said, the first approach, there are some concern, but I know that some institute, they agree to do that aggregated data, which has not lead to any specific information that violate the privacy.
Okay. So you mean to say that we need to be very careful while considering the features.
Exactly.
By training the data, while training the data.
Yeah. If you want to take the features from the central location, right? So we need to have again the concern of that aggregated or the features has some specific information that violate the privacy or that reveals any privacy of that one. So the better approach is, no, don't take that the event features. You train a model inside that particular location, take the parameters out of that one, and then to aggregate into the central model.
Hi, I've got a question for Sean.
Go ahead, Catherine.
Thanks.
Yes, Catherine.
Sean, your presentation was extremely timely. So what I thought was fantastic was that you said that you used mobile-based data and you actually found that movement in poorer parts of the city was greater than wealthier areas.
Yes.
What an amazing insight, because we are doing this pedestrian counting index and we're right at the end of the findings and working with University of Wollongong. Can you just share with me a little bit more detail as to how you actually came to that conclusion? I'm really interested to understand, first of all, how you got access to the mobile-based data, but that's a fantastic insight. Because, and are there some other kind of high-level insights that helped you to lead on to that conclusion?
Cool. So we had worked with Statistics New Zealand for many years on their setting up of data ventures, which is a sort of quasi-government company. It's a bit hard to explain what it is, but it does good things. What they've done is they have purchased mobile data from all of the major carriers in New Zealand. They amalgamate it into a single API and then index it against the index data held by Statistics New Zealand, which is how we can infer things like decile, deprivation deciles, that sort of thing. So that arrives in a feed. Originally what we were doing is looking to construct city level bubbles. We were mainly looking at the very vulnerable populations we have, particularly in apartment blocks, but there are some others. And we were looking to see how would the disease arrive in that neighborhood, and then trying to figure out, if we know the vector, how do we deflect it, essentially. The decile, the movement rating came a little bit later on, because once we had started to figure out how things were moving between, how people were moving at a population level between the different bubbles, we started to look into why they were moving, and I can send you the report if you like. The other thing we were looking at was if we had to move to a further level of response, where we would create city scale bubbles. So if we look at Victoria, one of the things I noticed was they used a political border, not an economic border, to isolate the state, which naturally cuts communities in two that just happen to have a state line between them. Mm-hmm. It would probably be much easier to use economic geography and isolate those border communities effectively in a buffer zone of their own. And
that is absolutely fantastic. We have applied, we've actually used economic and social indicators as the determinant of the clusters. So wow, this is fantastic.
Yeah.
Sean, I would be very interested if it was public access to have a look at the high-level report. And I suppose what I just want to highlight is this is a really amazing example where city-generated data. So this is, you know, pedestrian flow, movement of cities, the ability that you have this capability is really effective. And if there's one thing for sure, cities are really hungry for this sort of, you know, collaboration. So. Thank you. That was really very insightful. And I also love the next speaker around, you know, the models. So I've found this session really valuable. Thank you so much.
Thanks, Catherine.
Any other questions for our speakers?
Yes, it's Richard here, Richard Murcott. A question for Sean. Hello, Sean. And thank you.
Hello, Richard.
Thank you for your presentation this morning. Really good. Just something that caught my attention. I think you said you mentioned the app rolled out to 800 businesses. The Ripple app. Yes. Help people locate themselves and things. And I think you mentioned a 20% uptake. of course, I'm aware that the national government, the health ministry, and the Health Information Standards Organisation developed an app for use and promoted nationally. Was there a bit of competition going on there? Did that upset the uptake, or any feedback on that?
So we were left in a fairly invidious position where there wasn't competition because the government didn't have an app at that point.
Right.
And so that was why we were essentially forced to act. Believe me, I had been in touch with the Cabinet Office and with the Health Ministry trying to figure out how we adopted the government app, but they couldn't tell me anything and they didn't have anything. So what we did is we took the draft health standards and used those as part of our criteria. And so we've essentially set the city on a convergence path. So if you use Ripple, you can scan either a Ripple code or a national code. And we've used that standards base to effectively get down to a single codes. I would have much preferred simply to have adopted the government solution. I'm a good public servant, but unfortunately that option wasn't available to me at the time.
Understand.
Sean, I have the questions to you regarding this mobile data.
Yes.
Yeah. So how do you concern this privacy issues with mobile data?
So that is why Statistics New Zealand are involved. They provide the privacy layer at the top. So we're measuring the flow of population, not individual people. So it's also the reason why there are restricted geographies. So this is very much useful at a community scale. It's not very useful at a street scale, so it doesn't go down far enough for that. Before we apply, we have two processes essentially, both of them based on privacy impact assessments. When we take data in, we do a very quick assessment of it to see whether it contains a danger. Then when we use it and apply it, we do another one, which is basically saying we're combining this with other things, we're using it in a way it may not have been intended for use. Are we creating danger through our actions? And between the two things, that's how we control the privacy.
So then if you consider the quarantine, the individual quarantine, so you need to have the individual information.
Bear in mind, we're not the public health authorities. The public health authorities are the ones exercising the ability to individually quarantine people. What I'm interested in is the flows of people that may have those individuals in them. So we, for example, knew there was a case in a mesh block in the east of the city.
Yeah.
We didn't know which house that was in. The other point to make is you have two regimes in place there. The data governance structure we use is an open, a shared, and a closed data system. The closed data system is the one that has any private details in it. Yeah. The shared data system is the one we share with other agencies. That is generally anonymized unless there's a very good reason why it's not. If it's not anonymized, it's bound by MOU and use and disclosure regimes. And then if it's open, then it's fully anonymized and anybody can use it. So between that, we're relatively confident we can do things. But to be fair, this emergency stretched that regime to as far as we could, because we had designed it for earthquakes. We hadn't designed it for pandemics.
Thanks, John.
Thank you very much, Sean. Right.
If any of you don't have any questions, I have a question for Nishantha. So I hope you have heard of edge computing, where the computing is happened at the end of the device itself, for example, in sensors.
Yeah.
How this federated AI can be related to edge computing? Yeah.
So once you build the model, so that you can do the edge computing only serving the model, not that in the training and anything. Like if you want to say, let's say if you want a mobile, if you want to have some updates based on your model, based on your findings, that you can use for the edge computing on that one. Rather than, I don't think that any training with the data, it can be happens on the as far as I know, right, in edge computing.
Thank you. Okay, so just being very cognizant of everybody's time and the fact that we are coming up to 12 o'clock, and I just want to maybe start the wrap-up process. So if there are no other questions for the speakers that we've had today, I just really want to take the time to say thank you so much for everybody, for our participants as well, for joining us, but our speakers. You really provided a range of food for thought this morning, so very grateful for your time, especially those, Catherine, who have joined us from Australia. And yeah, it's been really, really fantastic. So I guess just to give a very big thanks to everybody, and we have recorded the session. We will be sending it to all of our participants, and we will sort of put notes together in a more comprehensible kind of format and send them through. But yeah, it's been a very fantastic morning. We've heard from Min about agent-based models and short-term predictions, so data assimilation for where people might be during an emergency. That's obviously highly relevant to what we're thinking about. Catherine, you presented on the democratization of data and enabling communities to use sensors and hyper-localized data. That's really interesting for setting us up for our thinking on Thursday around earthquake early warning and community sensor networks. And then we had Grace this morning giving us a demonstration of data application in Christchurch. So again, it sets us up really nicely for our conversation on Thursday as well. We've heard about the benefits of robotics for public safety, the future back strategy, and digital transformation. And then our final two speakers, really interesting, thinking about digital twins. And I like what you said, Sean, around how to turn data into information. That was fantastic. And then the federated AI was a really interesting sort of combination of ideas there. So thank you, everybody. And we really do hope that you'll be able to connect with each other. And we look forward to our second session on Thursday. So anything else from either Nalani or Marion?
Yeah, just huge thanks to everyone. So same time on Thursday, that will be at 10. And today we kind of covered really broad topics, but on Thursday we'll be focusing a little bit more on earthquake early warning, but we'll also look at the different aspects of it, data, sensors, and people, and still on the streamline of the thought of smart resilient cities. So hopefully if you enjoyed today, you'll come on Thursday as well and bring in your ideas and questions. And thanks for participating.
Yes, big thank you all.
All right, we might, unless there's any other questions, we might sign off early because, yeah, just very cognizant of your time.
Thanks for sitting through with us for 2 hours. And thank you, and see you all on Thursday if you're joining. All right, see you, everyone.